Hello everyone. So in this lecture, I will talk about the existence of the nth roots of any positive real number. So the question, so I mean more precisely, that suppose we are given a positive integer n and a positive real number alpha, then there exists a unique real number x, such that x power n is equal to alpha. So as we have seen that there are many ways to answer this question. So uh, in this lecture I will provide a solution of this existence problem using the concept of intermediate value theorem. So let's start. So solution. So given n is inside n and alpha be a positive real number, so then to find an x inside R such that its n power is equal to alpha. So now just let us define a function f from R to R by f of x is equal to, or just let's say f of y equal to alpha, x power y power n minus alpha for all y inside R. Now it is easy to verify that the function f is continuous, because because y power n is continuous, alpha is a constant function, and hence it is continuous. So the hence y power n minus alpha is also continuous, right? Now if you put, so check that f is continuous. Okay, why? So just you can check this, and now let's now put y equal to 0. Okay, then f of 0 is equal to, that is 0 minus alpha is equal to minus alpha, so it is negative, since alpha is a positive real number, right? So we are given that alpha is a positive real number. Now so now if we can show that there exists an element in R such that its nth power is greater than alpha, then we are done, right? So that suppose if we are able to find an element, say beta in R such that beta power n is greater than alpha, suppose. So if we are able to find this kind of element, then f of beta is beta power n minus alpha, and which is strictly positive, right? So hence, so it means that f of 0 is less than 0 and f of beta is greater than 0. Hence, therefore, by intermediate value property or intermediate value theorem, there exists, and so there exists an R inside R such that f of x is equal to 0, right? So it means that x power n minus alpha is equal to 0. It means that x power n is equal to alpha. Okay. Right? So now it is just so now we have to show that is such. So now we have to ensure that such a beta exists, right? Such a beta exists. So how to prove this? So just recall. Archimedean property of real numbers. Archimedean property of R. Right? So it says that given any x inside R, okay, there exists an n naught inside n such that n naught is greater than x, right? So it is basically the Archimedean property. So now just so here just let me just call it some other name. So given any y inside R such that y not is greater than y not, so there exists ny such that ny is greater, so ny naught is greater than y naught, since ny naught, I mean it obviously depends on y naught, right? So here we have alpha inside R. So by Archimedean property, so there exists and n naught belongs to, so n alpha belongs to n, okay, natural numbers such that n alpha is greater than alpha, right? Still greater than alpha. So hence n naught alpha to the power n, so it is obviously greater or equal to n alpha, and it is strictly greater than alpha. So just call it beta. So therefore Hence we show that we prove that so hence we are done, right? Because our point was that, so if we are able to find such an element beta such that beta power n is greater than alpha, then this will implies that there exists an element x inside R such that x power n is equal to alpha, and by Archimedean and using Archimedean property of R, just we have finally shown that such an element beta exists. Okay, now the uniqueness part. So it is very easy. Suppose x prime belongs to R such that x prime to the power n it is equal to alpha, and also it is x power n, right? Now x power n is equal to x prime to the power n. Okay, this implies x prime inverse to the power n is equal to 1. Okay, right? Okay, so what can you say about this? So such an element, so such an x is always unique. So the answer is, so does this implies that x prime power x is equal to 1? So the answer is no. The answer is no, because if you take this element, so take alpha is equal to 1 and and n is equal to 2, right? So then if you take x is equal to 1 and x prime is equal to -1, then x square is equal to 1 is equal to x prime square, right? So but x is not equal to x prime, right? So it means that uniqueness is not guaranteed, right? So your exercise, under what condition the element x is would be unique, will be unique. Okay, so this is very easy. So just if you observe that when alpha power n is equal to 1 implies alpha equal to 1, then just when you observe that x naught power n is equal to 1 implies x naught is equal to 1, so under what, so what is the n should be, so that this x naught is equal to x naught power n is equal to 1 implies x naught is equal to 1. Okay, so this is the one approach to solve or to prove the existence of the nth roots of a positive real number. Okay, so see you in the next lecture.